Good morning dear students, welcome to Maths Bridge course. So in the previous class we discussed the topic of what? Quadratic equations. The continuation of that topic itself is complex numbers. That means I can say the evolution of the topic of what? Complex numbers comes from the topic of quadratic equations. Okay, in the quadratic equations we discussed the nature of the roots. Okay, in the nature of the roots we discussed three important points, that is, one is discriminant is greater than or equal to 0. One is discriminant is greater than 0, next discriminant is equal to 0, another thing is discriminant is less than 0. When I said discriminant is less than 0, we said that there are no roots or imaginary roots. That imaginary roots concept itself gave birth to the topic of what? Complex numbers. Okay, so let us discuss complex numbers today. So when it comes to complex numbers, okay, for your board exams, okay, when it comes to 11th or 12th board exams, whatever is there, okay, complex numbers, very simple questions they are asking, very simple questions, straightforward questions they are asking. But when it comes to competitive, okay, complex numbers standalone topic they are asking. Apart from that, they are mixing with some other concepts. Okay, they will mix with trigonometry or they will mix with calculus, something like that, they will ask the question. So even in functions chapter they are asking complex number based questions. So that's why the complex numbers, you have to understand each and every concept in very detailed way. You should have a lot of clarity. Okay, so let us get started. So like I told you, when it comes to complex numbers, it comes from what? Comes from the topic of what? Quadratic equations. It comes from the topic of what? Quadratic equations. So where discriminant, if it is here, if it is greater than 0, we say it has real and distinct roots. We say real and distinct roots. And if discriminant equal to 0, we will say real and equal roots. We say real and equal roots. Now if discriminant is less than 0, I told the graph also, it does not even touch x axis. So here it will be what? We say no roots. You used to say no roots. Up till 10th you are telling there were no roots. Actually they have the roots, but they are not real roots, they are having imaginary roots. They are having imaginary roots. So the complete detailed study on these imaginary roots is nothing but the complex numbers we are going to study. Okay, it's nothing but the complex numbers we will be studying. Okay, now when do we get imaginary roots? Suppose we say suppose let us take up a simple question like, see, if you are having x square plus 4x plus 7, if I take it, okay, this is the quadratic equation, x square plus 4x plus 7, okay, is equal to 0. If I want to find the roots for this, if I have to find the roots for this, let us use the formula method. I cannot factorize it, I will use the formula method. So formula method gives me, that is x is equal to minus b plus or minus square root of b square minus 4ac. This is what? Discriminant. Okay, divided by 2a, divided by 2a, divided by 2a. Before going to this, let us find out discriminant. What is that? B square minus 4ac. What does this value be? Okay, d is equal to, if I find out b square minus 4ac, b square is what here? B is 4, b square means it will become 16. Okay, 16 minus 4ac, 4 into 1 into 7, 4 into 7. So this will give us what? 16 minus 28, the value will be equal to what? Minus 12. So clearly it is what? Clearly it is less than 0, discriminant is less than 0, it has no roots, or we say it has imaginary roots. It has imaginary roots. We say it has imaginary roots. So what do you mean by that? Imaginary roots means, see here, how to write the imaginary roots. Now see here, I will substitute the value of b square minus 4ac here. What is the value we got? Minus 12. Okay, we got the value of discriminant as what? Minus 12, we got it. Now here what we can write it? X is equal to minus b. Minus b means what? It is minus 4 plus or minus square root of b square minus 4ac. B square minus 4ac is what, friends? It is minus 12. Okay, minus 12 divided by 2a. 2a means it is just 2 into 1. This is what we will be having. Now minus 12, I can simplify it. What I can do here? X is equal to minus 4 plus or minus. So 12 can be written as what? 4 into 3. So square root of 12 can be written as what? I can write it as square root of 4 into 3. So square root of 4 is what? 2. So 2 root 3 I can write it. But here what is happening? Minus is also there. So what I can write it here? Minus 4 plus or minus 2 square root of 3. Okay, square root of 3. It is not just root 3, square root of minus 3 is there. Okay, minus 3 is there, divided by 2, divided by 2. This is what we have. This is what we have, friends. Now this minus is a square root of a negative number does not exist. So for this what we have to do, the square root of minus 3, how I can write it is, here we are having square root of minus 3. So I can write it like this. So square root of 3 into square root of minus 1. Yes or no? Square root of 3 into square root of minus 1. So I got a positive value here. Here square root of minus 1, we call it as what? The imaginary number, that is we represent it by I. We represent it by I, which is nothing but we call it as iota. IOTA. This is called iota. Okay, this is called iota. So what will this become now? This will become x is equal to minus 4 plus or minus root 3, 2 root 3, it will become 2 root 3 into minus root 1, minus root of minus 1, correct na? Root of minus 1 will become what? Root of minus 1 is nothing but equal to what? I. 2 root 3 I divided by 2. So if I take 2 common and write it, so x value will become what? X value will become minus 2 plus or minus root 3 I. So this will be the value of x. So two values of x, minus 2 plus root 3 I, minus 2 minus root 3 I. So these are the two values of x, we got it. Okay, here it is not the important thing to find the value of x. Here I wanted to tell the concept of iota. So now let us discuss iota. So now you understood from where it is coming complex numbers. It is coming from the quadratic equation itself, where the discriminant is less than 0. When the discriminant is less than 0, what happens? Okay, we get an imaginary roots. We get imaginary roots. Now see here. Let us proceed. Now what is this iota? So iota is an imaginary number. Okay, I was telling you we get imaginary roots, that is represented by this iota. Iota is an imaginary number. It is defined as what? Square root of minus 1. That is, I told you, I can be written as what? Square root of minus 1. The value of I is what? Square root of minus 1. The value of I is square root of minus 1. So this is what they have given. So let us simplify this. So see here, let us discuss some more concepts when it comes to iota. So see, I told you I is what? Square root of minus 1. Square root of minus 1. So what about I square? I square will become what? Square root of minus 1 into square root of minus 1. So that is nothing but equal to what? Square root of minus 1 whole square. So that will become equal to what? 2 and square root will cancel. I will have what? Minus 1. Many people will think I square is plus 1. It is not plus 1. I square is what? Minus 1. I square is minus 1. We got it. What about I cube? I cube, you can write it as what? I cube, you can write it as I square into I. I square into I. I square value already we got it. That is nothing but what? Minus 1 into this I. So I cube will be equal to what? Minus I. I cube will be equal to what? Minus I. What about I power 4? What about I power 4? I power 4 will be, I power 4 will be, I power 4 can be written as what? I square whole square. Yes or no? Or you can write it just like this. I square into I square. But what is the value of I square? I square is what? Minus 1. So minus 1 into minus 1 gives us plus 1. So we got what? I power 4 is equal to what? Plus 1. Okay. Another important thing you must know, they will ask 1 by I. Okay, 1 by I, the value will be minus I. 1 by I, the value will be minus I. Clear? 1 by I, the value will be minus I. So simply put together here, let me write it here. The value of I is I itself, which is nothing but equal to square root of minus 1. The value of I square is equal to minus 1. Okay, the value of I cube is equal to minus I. The value of I power 4 is equal to what? Is equal to I power 4, the value is equal to plus 1. Now if you add all of this, I square, I cube, I power 4, what you will get? I minus I cancels, minus 1 plus 1 cancels, you will get the value as what? 0. So this is very important to know. I plus I square plus I cube plus I power 4. This value is equal to what? 0. You have to know this. Definitely you have to remember this value. So this value will be equal to what? 0. Now you have to know one more thing. I told you, that is 1 by I, the value is equal to what? Minus 1. 1 by I, the value is equal to what? Minus 1. Now what they will ask is, some bigger numbers they will give. They will ask you to find out the value. Suppose I say I power 247. What is the value of this? I power 247, what is the value of this? You know values up to I square, I cube, I power 4 you know. But how to know this value? Simply put together what you have to do, just divide by 4. Okay, if you know the divisibility rule by 4, you divide only the last two numbers by 4. The other number doesn't make any sense. Even if you divide complete number, doesn't make any sense. What you have to do for division by 4, divisibility rule you have to know. Divisibility rule by 4 says what? Last two digits should be divisible by 4. Last two digits should be divisible by 4. I am talking about divisibility rule by 4. Should be divisible by 4. This is what it says. Now, just a minute. Observe here. So, when you have to divide by 8, last 3 digits should be divisible by 8. If you have to divide by 16, last 4 digits should be divisible by 16. That means remainder should come equal to 0. If it is coming equal to 0, then that entire number is divisible by 4. Now, here 247 is there. Let us divide last 2 digits by 4. If I divide by 4, what I am getting? See, 4 ones are and 4 ones are. Remainder is what? Remainder is 3. Remainder is 3. Okay, remainder is 3. So, once I get the remainder 3, this entire value, that is I power 247 will become what? I power 3. Whatever is the remainder, write it to the power of I. So, I cube, what is the value? I cube, the value is minus I. I cube, the value is minus y. Like this, even if they give any bigger number, I power 225 or 2025, I power 2026, I power, what is they have given? 2027 if they give. Okay. So, 2025 they have given. 2025 means what I can write? So, divide by 4, what is the remainder you are getting? Divide by 4, you are getting the remainder as what? You are getting the remainder as you are getting the remainder as 1. So, this will become equal to what? Remainder I am talking about. Remainder will be 1, not the quotient. Please be careful here. I am talking about the remainder, not the quotient. Remainder only you have to focus. Here the remainder is what? 1. So, this will become what? I power 1. So, I power 1 is what? I itself. Now, if I say 2026, I power 2026. So, if I divide by 4, what is the value I will get? Remainder. Remainder is what? 2. So, I square. So, I square it will become, remainder is 2 here. So, I square it will become, so this will become, I power 2026 will become I square. I square value is what? Minus 1. I square value is what? Minus 1. Suppose we are having I power 2024. 2024 is there. So, what you will do? If you divide by 4, definitely it is completely divisible. 4 6 the. So, remainder is what here? 0. Remainder is 0 means what you will do? I power 0 you will write it. I power 0 means what is the value? Anything to the power of 0 is 1. So, here the value will be equal to what? 1. Here the value will be equal to what? 1. Clear? So, these are the basics you have to know when it comes to iota. Now, how they will ask the question is, see here, they will give summation I running from 1 to r, okay, 1 to 100, okay, summation I running from 1 to 100, they will give what? I running from 1 to 100, or they will give r running from 1 to 100, r running from 1 to 100, I power r they will give, okay, summation, this is what they will give, okay, r running from 1 to 100, I power r they will give, this is what they will give, I power r they will give, summation r running from 1 to 100, I power r they will give, okay, this is what they will give. Now, how to solve this question? Now, how to solve this question? So, for this question what you have to do? So, see here you will write it as what? You will write it as, first thing is what? I power 1, then I power 2, then I power 3, then I power 4, then I power 5, then I power 6, then I power 7, then I power 8, plus in the end you will be having I power 96, I power 97, plus I power 98, I power 99, plus I power 100. This is what you will be having. I told you the 4 values of I, that is I power 1, I square, I cube, I power 4. This value will become equal to what? 0. This will be equal to 0. This is what I told you here. This is what I told you here. Similarly, what will happen to this? This one will also become 0. Next four values of I, this will also become equal to 0. Okay, and in the end also if you do all these 4 values, this entire 4 values, these 4 values will become equal to what? 0. Okay, leave this. This will also become equal to what? 0. So, total value, so 0 plus 0 plus 0 it will become what? This will become equal to 0. This will become equal to 0. This is how you can solve this question. Okay. So, this is time consuming to write down all these things and do it. It will take some time. Okay, some other values are also given. So, what to do? For this we have a shortcut. What is the shortcut? What is the shortcut that you will follow? That is, here the values of n is what? The value of n is what? 1 to 100 means n will be equal to how much? Here n will be equal to 100. Okay, here n will be equal to 100. Okay, 1 to 100 means n will be equal to 100. If you divide by 4, here also you should divide by 4. Let it be any number, divide by 4. So 4 ones are 4 25s are. Remainder is what? Remainder is 0. Remainder is 0 means here remainder is telling us how many terms are there. Remainder is telling us how many terms are there. Here 0 means 0 terms left. 0 means 0 terms left. 0 terms left means the answer is what? 0 itself. Okay, the answer is what? 0 itself. So 1 to 100, 100 terms are there. Instead of doing like this, n is equal to 100, divide by 4. What is the remainder you are getting? Remainder is 0. Remainder is 0 means 0 terms are left. Remainder is 0 means 0 terms are left. So you are getting 0. Now let us take, okay, on similar lines, let us take one more question. Suppose they have given I running from, let us take it as some other value, I running from 1 to 50. I running from 1 to 50 or not I, let me take it as R. R running from 1 to 50, I power R is given. I power R is given. Now, what we have to do here, n value is what? 1 to 50 means n value is 50. If I write n is equal to 50, I have to divide n by what? I have to divide n by 4. Okay. N is what? 50. 50 by 4, what is the value I will get? So 4 12s are 48. Okay. What is the remainder? What is the remainder? Remainder here is 2. Remainder here is 2. Remainder here is 2. Okay. So how many terms are left? 2 terms are left. 2 terms are left. 2 terms left. So if you find out the value of these 2 terms, you will get the answer. Which are these 2 terms? These 2 terms can be either the beginning 2 terms or the ending 2 terms. Okay, 2 terms, either they can be either beginning 2 terms or ending 2 terms. Ending 2 terms. That means what? What I mean to say is beginning 2 terms are what? I1 plus I square. Ending 2 terms are what? They can be I power 49, I power 50. So out of these, you take any of the 2. I will take these 2. I will find out the value. I1 plus I power 1 plus I square. What is the value I will get? I is what? I is what? I will write it as I itself. I square is what? What is the value I will get? I square is minus 1. So what is the answer? I minus 1. So this is the value. So this is the value, we will take it. So this is the value, we will take it. Clear? This is how we can solve this question in a simplified way. Okay, no need to write down all the terms. Now suppose n you are getting 50, then fine. Suppose we will take one more question. Suppose it is given like this, summation, they have given R is from minus 4, okay, R is minus 4 to 99. R is minus 4 to 99. Okay. I power R is given. I power R is given. Now how to do this question? R is minus 4 to 99. How you will do this question? So the numbers what you will have, that is minus 4, okay, minus 3, minus 2, minus 1, 0, 1, 2, 3. It will go on up till 99. Now observe carefully. Here also you can use the shortcut, that is n is equal to whatever value you get divide by 4. Okay, you divide by 4 and whatever the remainder you get, that many terms are there, find out the value of those terms. Now see here, observe carefully, if I take from 1 to 100, there are 100 terms. If I take from 0 to 99, here also 100 terms are there. So here if you observe, if I take from 0 to 99, 100 terms are there. If I take 1 to 100, 100 terms, so 1 you reduce here and 1 you reduce here, so that will become what? 0 to 99, here also 100 terms are there. So here 100 terms, and what about this? How many terms are there here? Here how many terms are there? See here, 1, 2, 3, 4. Okay, 104 terms. Okay, 104 terms. So 104. So 100 terms plus 104. So 104 divided by 4. 104 divided by 4. What is the value I will get? Remainder here is what? 0. Okay, how many terms are left? Remainder is 0 means 0 terms are left. The answer is what? 0. The answer is what? 0. So for suppose this question only, if I say R is from minus 3 to 99. R is from minus 3 to 99. So the values will be what? Minus 3, minus 2, minus 1, 0, 1, 2, up till 99 it will go. So here also 0 to 99, 100 terms are there. And what about this? Minus 3 to minus 2, minus 1, 3 terms. So 103, n is equal to what? 103 divided by 4. 103 if I divide by 4, what is the remainder that I will be getting? The remainder will be 3. See, 102 is not divisible by 4. All even numbers are not divisible by 4. So you have to know. So here remainder will be what? If I divide, remainder will be 3. So how many terms left? That is 3 terms are left. 3 terms are left. Okay, 3 terms can be in the beginning or in the ending. 3 terms can be in the beginning or in the ending. But for simplified purpose, I will take the beginning terms itself. So what are the beginning terms that I have? They can be, so here I will write it, they can be I power minus 3, I power minus 2, I power minus 1. Okay, I power minus 1 plus. So I power minus 3, I know the value of I power 3, not minus 3. What I will do? I will bring it on, this will become I power 3 plus 1 by I square plus 1 by I. Okay, now 1 by, what is this? I cube is what? 1 by I cube is minus I. Okay, minus I. 1 by I square is what? Minus 1 plus 1 by I is what? Minus I. Okay, 1 by I is minus I. So here this minus I will take it this side. This will become 1 by minus of 1 by I. This will become what? Minus of 1 by I. This will be plus, or I can write this as what? Minus 1. This will be minus 1 minus I. So 1 by I is what? Minus I. So minus into minus, this will become plus. This will become plus I. This will become plus I. Okay, plus I. So plus I minus I cancels. I will have the answer as what? Minus 1. So the value of this summation I to the power of r, this value will be equal to what? This value will be equal to minus 1. Very simple. Okay. So using this shortcut, this is the way you can solve the question, friends. Okay. So that's all about iota. Let us see if there are any questions on iota. Yeah, we have a question on iota. So see, this is summation, means we have to add everything. This is pi, means it is the product. They are talking about the product. Okay. So this is x plus iy. What is this x plus iy? I will tell you. Okay. Going forward, I will tell you. So they have given summation k running from 0 to 100. K running from 0 to 100, I power k. Summation k is from 0 to not 100, it is 200, I power k. They are asking the value. Okay. Let me lower it. This is what they are asking. K is equal to 0 k to 200, I power k, they are asking the value, plus pi, that is p running from 1 to 50, I power p, they are asking the value. Now see here, summation means what? We have to add everything. So that will become what? 0 to 200. 0 to 200, how many terms are there? See, 1 to 100, 100 terms, 1 to 200, 200 terms, but 0 is also there. 0 to 200 means 201 terms. I am talking about this. 201 terms. So 201, if I divide by 4, 201 if I divide by 4, what is the value I will get? The value I will get is what? The value I will get is the remainder will be equal to 1. So remainder will be equal to 1 means that will be the first term. First term, that is only one term is left, that can be the last term or the first term. I will take the first term. First term here is what? K running from 0 to 200 means it will become I power 0. I power 0 is what? 1. Anything to the power of 0 is what? 1. So this value will get it as what? 1. This value we got it as what? 1. 1 plus we have to do this. What is this value? How to find out this value? They were given pi, means see I power 1 into I power 2 into I power 3 up till I power 50 we have to do, because pi means it is the product. So what we can do? You can use the law of exponents. Bases are same. Okay. Hello. Hello, pain. Okay, I am not able to read your this thing. Okay, anyways. Let me check if I am audible also. Okay, all right. So see here. So by using the law of exponents, that is a power m into a power n can be written as what? A power m plus n. So if you are having a power m into a power n, I can write it as what? A power m plus n. Similarly, here all the bases are same. I can write it as what? I power 1 plus 2 plus 3 plus 4 plus 5 plus up till 50. Okay, up till 50. Now I power, this is what we are having. Okay, we have got it in the form of summation. So summation up to 50, that is summation up to 50, that is sum of terms up till 50, that is summation of n, that is nothing but equal to what? N into n plus 1 by 2. So this will become what? I power n into n plus 1 by 2, that is 50 into 51 by 2. Okay, this will be what? 2 into 25. This is what we will have. So 25 into 51. 25 into 51. We have to find out this value and divide by 4, and we have to see what is the remainder we are getting. So 25 into 1 is what? 25 itself. Okay. 25 into 5 is what? 125. This is what? 125 plus 7 is what? 125 plus 2 is 1275. So we got what here? So here we got I to the power of 1275. 1275. Divide this by 4. Only last two digits divide by 4. So what is that value will get? Okay, if I divide by 4, this will be equal to what? Remainder will be equal to what? Remainder will be equal to 3. Remainder will be equal to 3. Here we are getting remainder is equal to what? 3. So what is happening here is 3 terms are left. So let us take the first 3 terms itself. So that will be equal to what? We will take the first 3 terms. So that will be equal to what? First 3 terms means this will become equal to I power what is that we are having? I power 1 into I power 1 plus 2 plus 3 we will take it. I power 1 plus 2 plus 3 we will take it. That is nothing but equal to I power 6. This if we divide by 4, what is that we will get? This if we divide by 4, remainder is what? 2. Remainder is 2 means that is nothing but what? I square. I square what is the value? Minus 1. I square what is the value? Minus 1. Okay. I square what is the value? Minus 1. So this we are getting as what? This value we got it as what? Minus 1. Now I can write it here. Okay. What is the value of summation I got? 1. Okay. This is what? Plus what is that I am getting? What is that I am getting? Minus 1. Okay. I am getting what here? 1 comma minus 1. This is what I am getting. X comma y. I am getting it as what? X plus iy they are telling. So this will become what? 1 comma minus 1, that is nothing but option 2. 1 comma minus 1, that is nothing but option 2. 1 comma minus 1, that is nothing but option 2. This is the way we have to simplify this value. This is the way ordered pair if I write it. X comma y, if I write it in the ordered pair, this is x, this is y, means I can write it as what? I can write it as 1 comma minus 1, that is nothing but equal to second option. Clear, friends? Let us go to the next question. They are asking the smallest positive integer n for which these two values are equal. These two values are equal. Smallest positive integer for which n, these two values are equal. So think about it, how to solve. Just think, give it a thought how to solve. See here, what we are doing is we got what? 7. So our remainder is 3. Remainder is 3 means instead of taking first 3 terms or something like this, because it is product, what I can take directly? I power 3 I can take it directly. Instead of doing like this, I can take directly I power 3. Even more simplified way I can get it. I power 3 is what? Minus I. So this value will become equal to what? This value will become equal to minus I. So ordered pair if they ask x plus iy. So x plus iy, that is nothing but equal to what? X value what we got? 1 minus I we got. So minus I means this is minus 1 I. So this is ordered pair, it will become 1 comma minus 1. So it is correct itself. So we got second option as the correct answer. But I cube you can take it instead of taking I square. Okay, I cube it will become minus I. I square is minus 1. So this is one small change you have to make. Next thing is, coming to this question, if you observe, they are asking the smallest positive integer n for which these two values are equal. We have to find out the smallest positive integer n. So what we can do here is, see here, 1 plus I to the power of 2n is equal to 1 minus I to the power of 2n. This is what is given. So we know that a power m into n can be written as what? A power m whole to the power of n. Yes, no. So what I can write? 1 plus I to the power of 2 whole to the power of n, I can do it. Similarly, same thing I can do here, 1 minus I to the power of 2 whole to the power of n, I can write it. Okay, this is what? A plus b whole square, this is a minus b whole square, that has applied. This will become what? 1 square is 1, I square, okay, plus 2i whole to the power of n. What about this one? This will become what? 1 plus I square minus 2i whole to the power of n. So this is what? 1 plus I square is what? Minus 1. Let me write it, 1 minus 1 plus 2i whole to the power of n. Here also 1 minus I square is what? Minus 1. This will be minus 1. This will be minus 1 minus 2i whole to the power of n. Okay, 1 minus 1 is 0, 1 minus 1 is 0. What will get here? Okay, 2 times I to the power of n is equal to minus 2 times I to the power of n. Okay, minus 2 times I to the power of n. So, this is possible. This is possible only when n is the multiples of what? 4. N is having the multiples of 4. Okay, n is the multiples of 4. This is possible only when n value is in the multiples of 4. Okay, so that means what? N value can be 0, 4, 8, okay, 12, like that it should go on. But they are telling positive integer. Positive integer means it can be 4, okay, but it cannot be 0. In positive integer we are not including 0. If they are telling non-negative, then you can include 0. They are telling positive integer means you should be careful. The answer is what? Smallest positive integer. Smallest positive integer means you will go with the option, that is answer is 4, which is nothing but first option. This is nothing but first option. Clear, friends? This is how you can solve this question. Now let us proceed to our complex numbers. Till now whatever we discussed is about the concept of what? Concept of iota. Why we discussed? Because they are asking many questions just on iota. Okay. Now let us enter into the topic of what? Complex numbers. Since you are already aware of iota now, this is just a extension of iota, that is what we are getting complex number. Complex number means what? See, before going to this, okay, so we know that numbers, the classification, how do we classify numbers? See here, if numbers, how do we classify? So here if you have a complete whole means, I told in the functions chapter also, okay, here we are having the complete real numbers, in the set of real numbers, okay, in the set of real numbers, okay, we are having something called, so the numbers, okay, if this is real numbers, this is real numbers means, okay, in the real numbers we have something called rational numbers, okay, rational numbers we represent it as what? These are rational numbers, we represent it by q, okay, we represent it by q, these are rational numbers, okay, rational numbers, these are irrational numbers, this is real numbers, we will write it as r, irrational numbers. From the real numbers, if you remove rational numbers, what you get? Irrational numbers, irrational numbers. In the rational numbers, further subdivision is there, that is in the rational numbers we have something like, okay, integers, that we write it as z or I, okay, in the integers also we have something like, okay, whole numbers. In the whole numbers, if you remove 0, we have what? Natural numbers. This is the classification. Outside, what is this? This is the complex number. This is the complex number. Okay, this is the complex number. Now, if you want to understand the complex number, see here. Okay, I told you we write it as what? We write it as imaginary roots. We write it using I. So suppose we are given a number. Okay, this is the complex number. Means z is equal to, we will write it as x plus iy. X plus iy, where x and y belongs to real numbers. Here you have to know x and y belongs to real numbers, but here there are two parts, x plus iy. Now here if you observe this part and this part, okay, this part and this part. So this part is called as the real part, and whatever is having I and the value, this part is called as the imaginary part. What is it? It is called as the imaginary part. Z is equal to x plus iy. Here only x is called as a real part, and I into y, that is called the imaginary part. So let us take some example. Suppose I write z is equal to 2 plus 3i. Here 2 is called the real part and 3i is called the imaginary part. But we know that 2 and 3 are real numbers. 2 and 3 belongs to real numbers. But I am talking about when we write x plus iy, this 2 is called the real part and 3i is called as what? Imaginary part. Okay, let us take one more example. Z is equal to, if I write minus 2 minus 2i. If I write this, here minus 2 is called real part. Here minus 2i or this 2i, okay, this minus 2i is called as what? Imaginary part. Clear? This is called as imaginary part. Now whenever we write z is equal to x plus iy, okay, this can also be written as an ordered pair. So I can write it as what? Z is equal to x comma y. So that is understood, this is real part and this is what imaginary part, it is understood. Here it is not representing x coordinate, y coordinate, here x is, here it is representing real part and y is representing imaginary part. That means I mean to say z is equal to, I can write as real comma imaginary, real comma imaginary. I can write it as an ordered pair, that is what they are telling. If x comma y belongs to real numbers, then an ordered pair x comma y can be equal to x plus iy is called a complex number. That is, z can be written as x plus iy, that can be written as an ordered pair x comma y, x comma y, x comma y. Now see here, if real of z is x is equal to 0, then z is called purely imaginary. If image of z, imaginary of z, y is equal to 0, then z is called purely real. What does it mean? So suppose I say z is equal to 2 plus 3i. Okay, I say I want real of z. Real of z means I want the real part of the z. That is nothing but what? Real of z is, this is the real part, I will write 2. If I say imaginary part of z, imaginary part of z means I should not write 3i. I is representing, it is an imaginary part, but it is not the number you should write. So imaginary part of z is what? Imaginary part of z is, I should write 3. Imaginary part of z means I should write it as what? 3. Okay, I should write it as what? 3. Clear? Okay, we should write it as what? 3. So this entire thing is imaginary, but out of that value is what? We should write 3. It is plus 3. Okay, imaginary part is 3. Now suppose I say, suppose some z is equal to x plus iy is given. Okay, if I say real of z is equal to 0, that means what? Real of z is equal to 0 means what? Real of z means here, let me write here, real of z means it is nothing but equal to x. Imaginary part of z, imaginary part of z means it is nothing but equal to y. If I say real of z means this, that means what? This x is equal to 0. It is implying, what is it implying? Real of z means it is implying x is equal to 0. Real of z is equal to 0 means the value of x is equal to 0. That means what? This complex number will have only x is equal to 0 means it will become iy. Okay, iy, only iy is there. That means it is not having only it is not having any real part. So I can say the complex number is having only imaginary part, or I can say the complex number is purely imaginary. The complex number is purely imaginary. The complex number is purely imaginary. I can say the complex number is purely imaginary. Okay. So similarly, if I say z is equal to x plus iy, if I say, okay, if I say imaginary part of z is equal to 0. Imaginary part of z is equal to 0. What is the imaginary part? That is nothing but y. Y is the imaginary part. That implies what? Y is equal to 0. Y is equal to, that means what? Y is equal to 0. Now we can write what? Complex number z is equal to what? X, just x, because y is 0 means 0 into I is, that is also 0. So z is equal to x. This is what? This complex number is called as what? Purely real. This is purely real. Purely real means what? There is no imaginary part. Purely imaginary means there is no real part. So why I am telling is, in the question, the given, suppose there is a purely imaginary complex number, that time you should know the concept. Purely imaginary complex number means there is no real part. Suppose there is a line passing through a purely real complex number. Purely real complex number means you should know there is no imaginary part. That is why this concept is important. Purely real and purely imaginary. Purely real and purely imaginary. Now let us see some examples for complex numbers. See the complex numbers, how we can represent is z is equal to, I can write it as 2 plus 3i. Another example I can write it as z is equal to 2 minus 2i, something like this. Okay, or z is equal to, I can write what? 2. This is what? Purely real. I can write it as z is equal to what? I can write it as just 2i. This is what? Purely imaginary. Or z is equal to, I can write minus 2. This I can write it as z is equal to minus 2i. This is what? Purely imaginary, purely real, purely real. Okay, these are the various ways we write the complex number, but basically we write it as what? X plus iy. Okay, but it doesn't mean that here only plus should come, minus can also come. Okay, so z is what? Z is a complex number. Now let us proceed. So properties are algebra operations on complex numbers. So see here, suppose they have given two complex numbers, z is equal to, let us take it as what? X1 plus I y1, let it be z1. Okay, another complex number is given, that is z2 is equal to x2 plus I y2. Okay, x2 plus I y2. Now suppose they ask you z1 plus z2, that is addition of the complex numbers. If they ask you z1 minus z2, how to do? Okay, this is given x1 plus I y1 plus, they are asking addition, right? So this will become x2 plus I y2. Okay, I y2. Here what is they are asking? What is it they are asking? They are asking subtraction, x1 plus, what is this? x1 plus I y1 plus x2 plus I y2. Subtraction, right? Here minus should come. Here minus will come. So what you have to do is very simple. Real part add to real part, imaginary part add to imaginary part. That's all. Okay. Real part add to real, subtract from real part, imaginary subtract from imaginary part. That's all. So this will become what? This will become x1 plus x2, x1 plus x2. Okay. Imaginary part. Now you have to add the imaginary part. So write I outside. So I outside. This will become what? y1 plus y2, y1 plus y2, y1 plus y2. That's all. Imaginary with imaginary, real with real, while addition and subtraction. Okay, subtraction here, see, this will become x1 minus x2, real with real, while addition and subtraction. Imaginary, this will become what? This will become what will happen to this? This will become plus I, plus only will come I. What will happen? y1 minus y2, y1 minus y2. This is what happens when it comes to addition and subtraction. This is what happens when it comes to addition and subtraction. Now what about the multiplication? So multiplication, what will happen is z1 z2, if I do multiplication, what will happen is, so just like normal multiplication how you do, that's all you have to do. x1 plus I y1 into x2 plus I y2, just directly multiply. So x1 into x2 is what? x1 x2. x1 into y2 is what? This will become plus I into x1 y2. Then I y1 into x2 is what? Plus I into, what is that I am having? I into y1 x2 plus I into y1 plus I into y2, that is what? I into I is I square. So this will become plus I square into y1 y2. Now let us simplify this. This multiplication. x1 x2, this will become what? x1 x2 is what? Plus I into, what I can write? I can take common here, it will become what? x1 y2 plus y1 x2. So what about this? This is I square, that is nothing but what? Minus. I square is nothing but what? Minus 1 minus y1 y2. So this simply put together, I can write it as what? This one I can write it as what? x1 z1 z2, I can write it as x1 x2 minus y1 y2, okay, plus I into x1 y2 plus y1 x2. That's all. Okay, that's all. Should you remember this formula? No, no need to remember. Just do the multiplication. Just do the simple basic multiplication. So let us take an example for multiplication. Suppose we are given z is equal to 2 plus 3i is one complex number z1. Another complex number z2 is given as 1 plus 2i. This is what is given. So we want z1 z2. How do you do the multiplication? Just write down like this: 2 plus 3i into, what is it? 1 plus 2i. You don't have to remember that formula what we got, no need to remember. Just do direct multiplication, 2 into 1 and 2 into 2i. So 2 into 1 is what? 2. 2 into 2i is what? 2 to the 4, 4i. Okay, next 3i into 1, 3i into 2i. So 3i into 1 is what? That is 3i. Okay, that is what? 3i. Next 3i into 2i is what? That is 3 2s are 6. I into I is what? I square. This is what we got. Now see here, 2 plus 4i plus 3i is what? Imaginary part, I can add it, this will become 7i. Okay, plus 6 into I square is what? Minus 1. So what we are having? 2 minus 6 plus 7i. 2 minus 6 is what? Minus 4 plus 7i. This is what the value we will get on multiplying. So this is about the multiplication of complex numbers. This is about the multiplication of complex numbers, friends. Clear? Now let us see some other properties that are there. So properties of algebraic expressions, that is algebraic operations. Addition, subtraction I told you. Okay, so I told you about the what is that? Multiplication also I told you. this z1 will be equal to z2 if x1 is equal to, if and only if x1 is equal to x2 and y1 is equal to y2. That is, two complex numbers are equal if and only if the real parts are equal and the imaginary parts are equal. That is, real part of one complex number should be equal to real part of another complex number, and imaginary part of one complex number should be equal to imaginary part of another complex number. That means, suppose I write z is equal to 2 plus 3i. Okay, another complex number I write z is equal to 2 minus 3i. Here what is happening? Real parts are equal, that is, real parts are 2 and 2. But what about the imaginary parts? Here it is plus 3, here it is minus 3. So z1 is not equal to z2. So if I write z is equal to 2 plus 3i and z2 is equal to 2 plus 3i, so definitely it is equal. This is what 2, x1 and x2, this is what 2, here also it is 2, real imaginary part 3i, this is also 3i, so they are definitely equal. Okay, definitely they are equal, that is what it means. Additive inverse, additive inverse of a complex number, additive inverse of z is minus z. Okay, additive inverse of z is you have to take minus z, that's it. So for taking additive inverse, okay, z is a complex number, for this additive inverse is what? Minus z. Okay, you have to just write minus z, just multiply with minus, whatever the value is given, just multiply with minus. So suppose z is given as 2 plus 3i. If they ask additive inverse, you have to write what? Minus z. That means what? This will become minus 2 minus 3i. It will just become minus 2 minus 3i. Clear? This is about additive inverse. Now when it comes to multiplicative inverse, okay, you have to understand multiplicative inverse means you have to know what is conjugate of a complex numbers. About all these topics we will be discussing in the next class. So in the next class we will be discussing about conjugate of a complex number and multiplicative inverse and related concepts. Alright friends, thank you. Let's meet in the tomorrow session.